So in this video, I don't really have a PowerPoint for this one. I may try to add one later. I think the video may give you enough information though. We have the power rule and the quotient rule. And as you saw in the write-up in Canvas on this, I have a different way of using these rules. So I say that the power rule, right? If I have f of x times g of x, and I want to know the derivative of this thing, the derivative with respect to x is equal to 1d2 plus 2d1. And if you wanted to see, well, how on earth would I apply that here? Well, my first function would be the f of x, right? And my second function would be the g of x. So when I talk about 1d2, 2d1, I don't mean the number one. I mean the first and second terms here. So then the derivative of the first term is going to be f prime of x, and the derivative of the second term is going to be g prime of x. So if I were to go in and make these substitutions, right, then I would have f of x times g prime of x, right, because d2 is g prime of x, plus the second function is g of x times the derivative of the first f prime of x. So here's the derivative of that product, okay? And you know, the 1d2 plus 2d1 is just an easy way for me to remember what that is, okay? And the same thing applies with the quotient rule. So if I want the derivative with respect to x of f of x over g of x, I say that derivative is low d high minus high d low over low low, okay? So I can go in and identify what the high function is. So in this case, the high function is going to be f of x. And the derivative of the high function is going to be f prime of x, right? So, you know, again, just some corny way of me writing the problem so that it's, or the rule so that it's easy to remember. The low is going to be g of x, right? If you're looking at the original problem, and the d low is going to be g prime of x. D low, g prime of x. So if I wanted the derivative of this thing, right, then I would say low d high, right? So the low is g of x, times the derivative of the high, f prime of x, minus the high, which is f of x, times the derivative of the low, g prime of x, over low low. So when we write low low, what we mean is whatever's on the bottom, right? G of x times g of x. So let's take a look at a couple of problems. I'm going to do a power rule problem for you. Then I'll do a quotient rule. And then there's another video that I'm going to post of an interesting problem from Newton that I want to address, just so that you have all the information you need here. So if I take a look at this problem here, and this is another problem directly from Newton, I'm going to have h of x equal to 3x squared plus 5 times negative 2x to the third minus 5x. And I want to find h prime of x. Okay, so what I want to do is identify what is the 1. In other words, the first term. And the first term here is 3x squared plus 5. I don't really need that parenthesis there. The d1 would just be the derivative of this thing, or 6x. Then I'm going to go and identify what the second term is. And in this case, the second term is negative 2x to the third minus 5x. The derivative of the second term is negative 6x squared minus 5. So if I wanted to know, so what's the derivative? What is h prime of x equal to? It's going to equal the first term, 3x squared plus 5, times the derivative of the second term, negative 6x squared minus 5, plus the second term, negative 2x to the third minus 5x, times the derivative of the first term, 6x. And so we wouldn't leave it like this. We're going to go in and actually multiply this out. I'm going to have 3 times negative 6, that's negative 18x to the fourth minus 15x squared minus 30x squared minus 25. So again, I'm really just I'm foiling this out or distributing, whatever you want to call it. Now I'm going to add in this term, negative 12x to the fourth minus 30x squared. There's some like terms and things that I can combine right here. This will give me negative 30x to the fourth. One of the things that I like to do is go mark these things out when I'm done. So this is negative 60x squared. Here's a negative 75x squared. Okay, I've combined all the x squareds. And then it's a matter of, I got a negative 25 right here. I think I may have, I'm double checking. Let me make sure that I didn't get my terms crossed up. If y'all don't mind, I apologize, but I want to make sure that I was looking in the right place. And I don't want to confuse you. So I'm going to go and just multiply this out again. Negative 18x to the fourth minus 15x squared minus 30x squared minus 25. And then minus 12x to the fourth minus 30x squared. Okay, good. I think I had the right thing. I just wanted to verify that everything was good. These two we said would give me negative 30x to the fourth. This is going to be negative 75x squared minus 25. So that's what I would type in as my derivative for this particular problem. So we want to look at a quotient rule too, just to make sure that you know how to use the quotient rule, when to use the quotient rule, right? How do I know when the appropriate time is? Let's take a look at this function here. So h of x is going to equal negative 10x over 3x squared minus 7x minus 5. I've been having a little bit of an issue with my right eye, and so some things are a little blurry here, and that's why I had to erase a minute ago. I wanted to make sure I didn't have anything mixed up there, and we're good to go now. So the high, right? Remember when we do the derivative of this thing, the derivative is going to be low d high minus high d low over low, okay? So the high is going to be negative 10x, and the derivative of the high is negative 10. The low is 3x squared minus 7x minus 5, and the d low is going to be 6x minus 7. Okay? Real quickly, we'll go in and we'll say low d high. So low, right? Low is this guy right here, low d high. I'm going to have 3x squared minus 7x minus 5. We're going to multiply that by negative 10 minus high d low, right? So I'm going to have the high function, which is going to be negative 10x. I'm going to multiply that by the d low. The quotient rule is the more complicated of the two. It's just, quotients and sums and differences. They all have their quirks. So here we're going to do low. So we're just going to have, let me do this in a different color here. We'll go yellow. We're going to have the term on the bottom, the denominator, we're going to square that, right? Low means to multiply it by itself. So there is some simplifying we can do. We'll take that real quick and we'll do that here. So I'm going to have the denominator 3x squared minus 7x minus 5, that quantity squared. And I'm just going to write above here. Okay, so 3 times negative 10, negative 30 x squared plus 70x plus 50. So I can go ahead and call this a positive 10x. That would give me plus 60x squared minus 70x. And now when I combine those like terms, I have a positive 30x squared because those two will cancel. The 70x's will cancel, and I'm left with plus 5. And that is as far as I can go. So if you wouldn't mind, tune in to the next video because there is an interesting one from Newton that I want to show you, just so that you're not completely off guard by what you see. It's a graph and a table, and there's some things that are implied, not very obvious.